This is NASA's Vehicle Assembly Building, or VOB, one of the largest structures of its kind on Earth. For more than half a century, it has been the site where some of humanity's most powerful rockets were assembled, prepared for launch to space. Let's explore what's inside this iconic building and how it's been used through different eras of space exploration. A structure for giant rockets in the 1960s, NASA needed a dedicated facility to assemble the Saturn V rocket, the massive launch vehicle that would carry astronauts to the moon as part of the Apollo program. At the time, the launch pads weren't equipped for vertical rocket assembly, so NASA built the VOB, a colossal indoor workspace designed to safely stack rocket components protected from the weather. Even today, this building continues to play a key role in preparing rockets for launch. Purpose and design: the VOB provides a controlled indoor environment. Rockets are assembled here and remain protected until they are moved to the nearby launch pads, typically a few weeks before launch. Over the decades, it has supported three major rocket systems: the Saturn V, Apollo program, the Space Shuttle, the Space Launch System, SLS, for the ongoing Artemis missions. Construction of the VOB began in 1963 and took 3 years to complete. The building cost approximately $117 million at the time, equivalent to over $1 billion today. Outside, it displays a massive American flag and the NASA logo. Size and layout: the VOB is located at NASA's Kennedy Space Center in Florida. It's about 160 meters, 525 feet, tall, taller than the Statue of Liberty, and nearly as tall as the Eiffel Tower. The facility includes several areas: low bays, for working on smaller components; high bays, tall, open areas for stacking full rockets; transfer aisle, a central corridor used to move large parts between the bays. Each high bay is served by massive cranes. The strongest cranes can lift nearly 300 metric tons, essential for carefully maneuvering rocket stages. There are retractable doors on each side of the building. Opening one fully can take up to 45 minutes. Transport to the launch pad: once a rocket is assembled, it's placed on a mobile launcher platform and transported to the launch pad using the crawler transporter, a slow-moving, heavy-duty vehicle designed specifically for this task. The pathway it travels is called the crawlerway, a specially constructed double-lane roadway that extends over 5 kilometers to the launch pads. Apollo era: during the Apollo missions, most rocket assembly took place in high bays 1 and 3. The massive Saturn V rocket was brought in stage by stage. The first stage was placed on the mobile launcher. Then the second stage, third stage, and the instrument unit was stacked. Finally, the command module and lunar module were attached at the top. Each part was lifted using cranes and surrounded by work platforms. Space Shuttle program: with the end of the Apollo missions, NASA transitioned to the Space Shuttle, a reusable spacecraft system. To support the shuttle, the VOB underwent several changes. Work platforms were reconfigured for the shuttle's shorter height. The transfer aisle entrance was widened. Dedicated checkout cells were added to store fuel tanks and shuttle components. The shuttle stack consisted of 2 solid rocket boosters, an external fuel tank, and the orbiter itself. Each part was carefully lifted and connected using the building's cranes before being transported to the launch pad by the crawler. Artemis program and SLS: after the shuttle's retirement in 2011, the VOB was upgraded for NASA's Artemis program, which aims to return astronauts to the moon. This required a full modernization of the building. Thousands of cables and systems were replaced. New adjustable platforms were installed for the Space Launch System, SLS, a powerful new rocket. The crawler and mobile launch platform were upgraded to support the heavier SLS rocket. Just like before, the solid rocket boosters are stacked first, followed by the core stage, and finally the Orion spacecraft on top. A legacy of innovation. The VOB is more than just a building. It's a symbol of human ingenuity, a place where some of the most ambitious missions in history have taken shape. From the moon landings, to building the International Space Station, to preparing for future lunar exploration, this structure continues to support bold new chapters in spaceflight. And as long as we keep reaching for the stars,